In the summer of 1977, amid the backdrop of the Cold War and a rapidly changing world, NASA launched two spacecraft that would embark on a mission unlike anything humanity had ever attempted. Voyager 1 and Voyager 2 were twin robotic emissaries, each no bigger than a compact car, built not just to visit the distant planets of our solar system but to sail beyond them, into the unknown vastness of interstellar space. These weren't just scientific missions, they were bold expressions of our species' endless curiosity and hope, powered by 1970s ingenuity and the dreams of engineers and scientists who dared to push the limits of what was possible. The Voyagers were designed to take advantage of a rare planetary alignment that only occurs once every 176 years. This celestial lineup allowed the spacecraft to perform gravity-assist maneuvers, essentially using the pull of one planet to sling them toward the next. With this technique, they could complete their grand tour of the outer planets in a fraction of the time and fuel that would otherwise be required. It was a shot in the dark, and it worked. Equipped with what was then cutting-edge technology, these spacecraft set off on an odyssey through the gas and ice giants, returning images and data that would rewrite the textbooks and redefine our place in the universe. Their onboard instruments recorded magnetic fields, radiation belts, atmospheric compositions, temperatures, and more. But beyond the data, they captured something deeply human, a sense of wonder, of reaching out into the night sky with open hands and asking, "What's out there?" Voyager 1 and Voyager 2 each carried with them a remarkable artifact, the Golden Record. Carefully mounted on the side of each spacecraft, this gold-plated copper disc served as a time capsule and a greeting. Crafted under the guidance of astronomer Carl Sagan, it contained the sounds of waves, wind, birds, and a mother's heartbeat. Greetings in 55 languages, classical music and rock and roll, mathematical diagrams and images of daily life on Earth. The Golden Record wasn't just a message to aliens, it was a mirror held up to ourselves, a declaration that we were here, we had culture, we had love, and we longed to connect. As the Voyagers moved outward, their cameras and sensors brought home breathtaking glimpses of distant worlds. Voyager 1 was the first to reach Jupiter, capturing high-resolution images of the Great Red Spot and discovering volcanic activity on Io, one of Jupiter's moons, the first time active volcanoes had been observed beyond Earth. Then came Saturn, where Voyager 1 revealed the complexity of its ring system and discovered new moons hidden within the planet's orbit. By the time Voyager 2 reached Saturn in 1981, mission scientists had learned much from its predecessor. Using that knowledge, Voyager 2 was able to uncover even deeper secrets. It found that Saturn's rings weren't solid bands at all, but dynamic, ever-changing streams of icy particles, twisting, bending, and clumping in ways that defied old assumptions. This was no orderly celestial ornament. It was a roiling, living system that reflected the chaos and elegance of the universe itself. In 1986, Voyager 2 achieved what no other human-made object ever had. It flew past Uranus. The spacecraft revealed this mysterious, pale blue planet in unprecedented detail, capturing images of its atmosphere, discovering 2 new rings, and identifying 11 previously unknown moons. Uranus, unlike any other planet in the solar system, is tipped on its side with an axial tilt of nearly 98 degrees, likely the result of a massive collision long ago. Voyager 2 also passed through the planet's magnetosphere, gathering clues about its unusual magnetic field, which was both offset from the planet's center and oddly angled, suggesting a complex internal structure still not fully understood today. The temperatures Voyager 2 recorded were astonishing, nearly minus 353 degrees Fahrenheit. It encountered a massive magnetic bubble or plasmoid escaping from the planet, offering a glimpse into the way even distant planets interact with solar wind. All of this, from a spacecraft already nearly a decade beyond its planned lifespan. Then, in 1989, Voyager 2 reached Neptune, the last of the gas giants. With this flyby, it became the only spacecraft to ever visit the blue planet. Neptune did not disappoint. Its winds were clocked at 200 miles per hour, the fastest recorded in the solar system. Voyager revealed a giant storm, the Great Dark Spot, along with a dynamic atmosphere brimming with methane and hidden patterns of circulation. It also turned its lens on Triton, Neptune's largest moon, where it discovered nitrogen geysers and a surface so cold that it defied the imagination. These features hinted at the possibility of a hidden ocean beneath Triton's crust, raising the tantalizing question, could life exist in such a distant, frozen corner of the solar system? But perhaps no single image captured by the Voyagers moved people more deeply than one taken after their main planetary missions had ended. In 1990, at the urging of Carl Sagan, Voyager 1 turned its camera back toward Earth from more than 4 billion miles away and snapped a photograph that would become known as the pale blue dot. Our entire planet, everything we've ever known, appeared as a tiny speck, a mere 0.12 pixel in size, floating in a shaft of sunlight against the vast darkness of space. That image remains one of the most iconic photographs in history, a reminder of our fragility, our unity, and the need for humility in the face of the cosmos. The story didn't end there. In 2012, Voyager 1 crossed the boundary of the heliosphere, the protective bubble of solar wind that surrounds our planetary system, and became the first human-made object to enter interstellar space. Voyager 2 followed 6 years later, in 2018. Even now, as they drift through the cold, silent dark between stars, these spacecraft continue to gather data. Most recently, Voyager 2's instruments picked up a low-frequency hum of plasma waves, essentially the background music of interstellar space. It marked the first sustained measurement of plasma density in this mysterious realm, offering clues about the environment that exists between solar systems. Though both spacecraft are now more than 14 billion miles from home, they still communicate with Earth. It takes over 18 hours for a signal to make the journey one way. With power systems barely able to sustain themselves, running on less energy than a standard light bulb, the mission team has been forced to make difficult choices, shutting down non-essential instruments to keep the core functions alive. Every bit of data that returns is a triumph of engineering, persistence, and faith in the human spirit. Voyager 2's legacy has done more than fill pages in scientific journals. It has shaped the way we think about our place in the cosmos. Its discoveries have helped design new spacecraft and inspired missions to icy moons like Europa and Enceladus, where oceans beneath the ice may harbor life. The mission's data have even influenced the search for Earth-like planets around other stars, providing a foundation for the next generation of planetary explorers. And yet, the spacecraft itself is now entering its final chapter. Slowly, piece by piece, systems will go dark. One day, the last whisper of data will arrive. But even then, Voyager 2 will continue its silent journey, uncharted, unbothered, and unforgotten. It will drift through the Milky Way for billions of years, long after humanity is gone. A small metal witness to our dreams and a monument to the age when we first reached for the stars. Voyager 2's mission is more than just a tale of technology. It's a story of human determination, imagination, and resilience. It represents the best of what we can be when we dare to look beyond the horizon. And though its light may fade, its message will endure, that we were here, and we had the courage to explore.